Hi everyone. I wanted to talk you through how to do this problem that I have in the lab handout. And here it says draw a dilution scheme in which you have 1 to 100, 1 to 1,000, 1 to 10,000, and 1 to 100,000 plates. So in the previous questions, we were just doing the dilutions. So we were doing that already and you were putting down the various dilutions. So you're just going to do that again. You can draw the little pictures of the bottles, the 99 ml bottle. Look, I have to fix that. 99 ml bottle, and then the 9 mils of water. So here we are. What you did is you took your sample and you can put it right into a bottle and get a 1 to 100 dilution. Now, there's lots of times more than one way to do this. We could have put it into a 9 ml tube and had a 1 to 10 dilution, and another 9 ml tube and had a 1 to 100 dilution. Or we could do it like this. We just got a 1 to 100 this way. Okay, so I made a 1 to 100 dilution. So there's that. I need a 1 to 1,000 and a 1 to 100, 1 to 10,000. There we go. Now I said to make plates 1 to 100, 1 to 1,000, 1 to 10,000, and 1 to 100,000. So we can do that. We can make your plates by taking a milliliter from the bottle and putting it on that agar plate. And if we want to know the number of bacteria in a milliliter, the dilution on the plate will be the same as the bottle. So we put a milliliter from there into that. We put a milliliter from our 1 to 1,000 on the plate. We have a 1 to 1,000 dilution on our plate. We take a milliliter from our 1 to 10,000 tube, and I have a 1 to 10,000 plate. Now I could do one more tube and a 9 ml tube and have a 1 to 100,000 and put that on this plate, 1 ml on this plate, and I would have a 1 to 100,000 dilution. In the virtual lab, they sometimes take they'll take their 1 ml out of here, 1 to 10,000 dilution. But if you take 0.1 ml, which is 10 times less than 1 ml, and I put it on the next plate, it's the same thing than if I would have made another tube here, if I would have had a 1 to 100,000 tube and put a milliliter on this. So this is just a way to save on one tube. And so on this, for this last one, my 1 to 10,000 dilution, if I put 1 milliliter on my agar plate, I have a 1 to 10,000 dilution. If I put 0.1 milliliter from here onto my plate, I have 1 to 100,000. You're going to see that on the virtual lab also. So the first thing the question asked me is draw a dilution scheme in which you have 1 to 100, 1 to 1,000, 1 to 10,000, 1 to 100,000 plates. So there's our 4 plates that we made. So after you've incubated these plates overnight, it says there are 80 colonies on the 1 to 1,000 plate. So on this plate, there's 80 colonies. You can count them. And so it says how many CFU, how many colony forming units, which we'll say is equivalent to the number of cells, are there in a milliliter of the original sample. 1 milliliter of the original sample. So here's our original sample, and we want to know how much is in here. And so what we do is we said if there's 80 colonies on here, we do 80 times what we call our dilution factor. So that's going to be this part of our dilution, 80 times 1,000. And so what is that? 80 plus 3 more zeros, because there's 3 zeros in 1,000. So that gives us, here we go, 80 with 3 more zeros. Okay. And so that's 80,000 CFUs are what are in a milliliter of this original sample. Now the question also asks you which plates are too numerous to count and too few to count. So if I'm at this plate, this was my countable plate. Actually, let me just back up and remind you that how do I know that was my countable plate? Because it had between 30 and 300 colonies. And statistically, that is the most accurate plate to count. So this plate had 80 colonies. That means this one, my TNTC, too numerous to count, had 10 times more colonies. Look at 1 to 100, 1 to 1,000. This is 10 times more concentrated. So this would have had 800 colonies. That would have been too hard to count. They would have been too close together and piled up on top of each other. Here, my next plate would be too few to count, because if this had 80 colonies, let's see, this one has 10 times fewer, so this would have had 8 colonies. And I'm telling you, the plate we want to count should have between 30 and 300. And that's because counting 80 colonies is going to make it more statistically accurate than if I count 8. And then this one should have 10 times less. So what that would be 0.8 should be like 0 to 1 colony, which show up on this. Okay, so both of these are FTC, too few to count. This one with 80 colonies is my countable plate, and this one with 800 colonies would be too numerous to count. So when you look at these plates, this is going to be the only one that will be the one that you will count. All the others you just toss.